Okay, so what we're going to be dealing with today is the last sort of data you can analyze in Dataviewer, and that is to use dynamic stimuli. So in this case here, we're dealing with a video, which is the most dynamic of dynamic stimuli, but it could be something as simple as having a moving target on a screen, or even having a sequential presentation of stimuli on the screen. It's just that videos are the most difficult, so I figured we would have a look at those. And so what I did is I actually grabbed this video off of YouTube. YouTube is great for one thing. It's good for cat videos. And also for posting lecture notes. And so what you actually have here is 6 subjects. Odd numbers are female, even numbers are males, looking at this video. And so by default, when you open up Dataviewer, it's going to open up in this trial spatial view. So what you're actually seeing here are all the eye movements over the entire trial, based off of one frame, which is usually the frame in the middle of the trial. So it kind of, when it's a video stimulus, what they'll do is they'll take a frame out and just use that as an overlay placeholder. So you can see I have a cat dressed up as a shark who's sitting on top of a Roomba, and this will obviously move backwards and forwards, cleaning the floor. And you can see that because you can see that these eye movements, those fixations, are kind of moving around here. But, this is kind of boring. We want to see what happens when this is actually a video. So what of course you can go and do is, if you go and click on the trial playback mode, you get to see the whole trial. So here the purple dot is my one participant where they're looking. So much like before, we can sit there and I can play this frame by frame. So you see down here this little the vertical line with the triangle. This will actually step forward, or I can use shift right arrow to step forward frame by frame, looking where the participant was looking at on the video. And of course I can do this at full speed, or I can do this slowed down. And you'll be able to save that as a video file at the top. Now, this is all very well and good, but say, for example, I now want to kind of take an average of where the actual person was looking at in terms of an area of interest. So what I could actually do is I can, if I just scroll back here, I want to say, okay, well, you can see from the eye movements, they're kind of dancing around. Sometimes the eye movements are on the cat, sometimes they're on the tail, sometimes they're on the Roomba, but they're all looking at that you could kind of say, well, in all the situations, they're looking at the cat Roomba object. And so what we can do is draw an area of interest around that. So if I go up here, I have my area of interest ellipse icon here. I can draw an ellipse that encompasses my cat. I'm going to make this a dynamic area of interest, and I'm going to label this something like cat. Okay. And when I do, it'll kind of highlight that as my area of interest. Now, what's important here is if you now go up to Inspector, because I label this as a dynamic area of interest, remember before, when we created an area of interest, we would have this sort of area of interest list here on the left-hand side. The difference when you make a dynamic area of interest, instead of having a single item, it creates a folder around that area of interest. I can look inside that folder, and right now, I only have one area of interest defined. Now, what I want to do is I want to have that area of interest move with the cat. So that it becomes dynamic, it actually moves. So there's two ways in which we can do this. Where is it? Here. If I click this and right-click it, there's something called mouse record. Mouse record is not that there's a mouse that's suddenly going to come on the screen. What it is that you'll suddenly get a mouse icon appear. And what you can do is click at a certain point in the video, and the area of interest will shift to that new location. Okay, so just to show you how this works, I'm going to click mouse record. I'm going to slow the video down quite a bit just to show you how this would work. I'm going to step forward a few frames. And then if I click here on the screen, you see my area of interest now shifts. And on the left-hand side, I've now got a second area of interest inside my folder. So again, I could then shuffle it forward a few more frames. I could recenter this, and another area of interest appears.
So if you're running an experiment and you're doing this through data analysis, would it be best if you did it at certain intervals of frames? I guess you'd have to stay consistent with regards to...
It doesn't matter. I'll show you why in a bit. Okay, so what happens here is we can sit there and I can manually shuffle forward a number of frames and move it. Or that gets really tedious, especially if you've got a video that lasts a few minutes. What you can actually do is play the video either at full speed or slowed down. And as it plays, I can click. So you can see here, so now the video is playing at a slower rate, but I can, every time I click on the screen, it shifts the area of interest. Okay, so what I've now got, you see, is I've got a time sequence here whereby between the first number and the second number, that's the frame area of interest. Then it shifts to the new location. Then it shifts. Then it shifts. And so for each time, you see, they're sequential. Each time frame, we're getting this shift in the area of interest. Okay. Now, what Karen was saying is quite true. It's like, in terms of, is there an ideal number of frames that you should move? The answer is no. And that's because if I play this back, so if I go back now to the beginning, I'm going to play the video back now, and I'm not going to touch it at all. What you'll see is that the areas shift now with the video. Now, the problem with this right now is you kind of have this, it's very juddery. So you kind of, it stays there, then it shifts, then it shifts, then it shifts. To remove that sort of juddering effect, you can actually interpolate between those locations. So to do that, if you go, I'm going to stop my video here. Yes, sure.
On my PC, I don't really have the option to pause, or anything.
Let me have a look.
So you click on the video icon.
Because you're on the spatial view, not the video view.
Yeah.
So they're at the top on the PC. It's okay. Okay, so to avoid that juddering effect, we can interpolate between the different areas. So if you go up to cat here, right mouse click, you can clean up the dynamic areas of interest. And then also on the inspection down here, this is, so you see here, this is my area of interest. It's called cat. I have 9 different areas of interest right now. Underneath the number of instances, there's this little tick box that says interpolate. If you click that box, what it will actually do is the software will then go through, and between those sort of locations, it will average the position and move it in a much smoother transition. So if I now go back and replay that video from the beginning, this is now with the interpolation enabled. So you see now it's moving on a frame per frame basis to follow the cat. So this is really useful, especially when you've got a stimulus that you can go through and you kind of map out every couple of frames, and especially when it's something that's quite predictable like this, like the cat is going in one direction, I can kind of guess where it's going, and so I can make it follow along on those different locations, and it interpolates between the two, and I get a nice now smooth transition of my areas of interest across the screen. By default, that interpolation occurs every 30 milliseconds. Okay, so if you go into your preferences and you go into the output analysis, you see here under the area of interest handling, there is this an additional box here that says interpolation interval in milliseconds. You can make that interpolation window smaller, and if so, you're going to have even shorter and even smoother transitions. Just be aware it does take the computer longer to actually analyze and handle the data when you do that. So every 30 milliseconds means that on average it's shifting that area of interest 3 times a second, which is not bad, especially when it's something that's fairly slow moving. Obviously, the faster the moving of the stimulus, you may want to actually interpolate more frequently to a faster moving stimulus. But overall, shifting it 3 times per second should be enough to generate a nice smooth transition in your areas of interest. So that is way number 1 in which you can define an area of interest, is by going in through and using mouse clicking. However, there is a second way, which again uses the same interpolation, but all you need to do is define a start point and an end point, and it'll actually interpolate between the two. Okay, so what do I mean by this? I'm just going to go back here, and I'm just going to delete my current area of interest, which I just made. Okay, because I'm going to show a second way of doing this. I'm going to take my video back to the start. Oh. Okay. What I can do is, instead of actually having that sort of clicking of individual areas of interest, I can create a new area of interest. I'm going to do that here. And I'm going to call this cat2. just to give it a different name. Okay. So right now, you can see cat2 is encompassing my cat quite nicely. What I'm going to do now is I'm going to kind of just start, I skip forward a little bit in the video. Okay, to about this point here. So what I can see is my cat has kind of moved in a straight line to this point over here. What I can actually do is take that current area of interest, copy it, and then paste to the current time frame. Okay, so this is different from regular paste. What it will do is that original area of interest was created back in time. We're now a few seconds down the line in our video. I'm going to now take that same area of interest and copy and paste it at the current time point. And I'm going to relate it to, and this is going to be related to cat2, because again, this is not a new area of point. This is a one that already exists, but it's now been moved and shifted in time. What do you mean? How do you get it saved?
So paste in paste current.
Right. Okay. So if I go, what happened there is I copy the old one, and then when you say paste current, then you get a sort of a second area of interest, and I can actually shift that with my arrow key here. Oh, I should be able to shift it. Why is it not shifting? Oh, yes. Oh. Option. There we go. So if you could relocate the area, so on a Mac you would press Option to here. So now I've got my original area of interest, which is in the past, and that same area of interest now has been moved in location to the current. And then again, as before, you go over to the cat, you right-click, you click Clean Up Dynamic Area of Interest, and then you interpolate. And what should happen now, if we go back to the original time point, if I now play the video, what should happen, if this works correctly, is I should now have an interpolation of that video, and that area of interest should move from this current location to the end location where it was. Every 30 milliseconds. Let's see if this worked. I'm going to speed this back up. So you see, my area of interest now moves with the cat.
Where is the option to change it to 30 milliseconds?
So if you go into the preferences, interpolations down there, okay? So this really is, those are the two different ways in which you can make a dynamic area of interest. Obviously, when you're dealing with something that's very predictably moving, then all you could do, especially in something like a straight line, you can mark the first part, you can skip forward a few seconds in the video, mark a second, interpolate between the two, and it does it all for you. However, if you have something that maybe is unpredictable in terms of direction or unpredictable in terms of the speed of movement, then you'll probably want to use the mouse click version. So again, what you can do is scroll through frame by frame, or you could play it back at a slower speed and just click at every few points, and then again, hit interpolate, and it'll smooth between those. Either way, this is a great way of then tracking a dynamic area of interest. And much like before when we were talking about areas of interest, when you now do your area of interest report, it will then give you how long did the person spend looking inside the area of interest, irrespective of where it was on the screen. So if you want to have, say for example, have the person tracking how many times they looked at the cat versus how many times they looked at the owner, you could actually separate the two and develop an area of interest around each. So you could have a human and a cat area of interest and have those both moving. The other cool thing as well is when you copy and paste that new area of interest in, along with moving, you can actually resize it as well. Now, I personally would not recommend that because obviously if you resize the area of interest, you're changing the size of the area. So if it's a smaller area, there may be fewer eye movements in it just because it's a smaller area. If you do resize it, then what you're going to have to do is somehow normalize your area of interest based on the area size of the area of interest. Again, that's possible. So, if you go into your area of interest, you have an area, you have the pixel area size here. So you can normalize your metrics based on the area size of the actual interest area if you do want to have changes in the actual size of the area of interest.
I noticed that when you do the dynamic, as in when it follows along by doing it in this way, if you see like the area of interest sort of limits to it doesn't seem to follow as fast as the little cat is going.
No, I mean, and so this is why in this case you can change those parameters. Again, here you would change it so that instead of shifting every 30 milliseconds, it shifts every 20 milliseconds, and you would have a better match. And you can play around with those, how fast or how slow the area of interest transitions. It's another option. Like I said, probably what would be more useful is to go through watching the video at a slow speed. I'm not saying go through frame by frame. That would be very tedious. But you can watch through and just every now and then click as you're going through where you think the area should be now located. And again, you can shift that around. And then so it actually closely matches your actual stimulus. And by doing that, then you'll get the nice smooth transition. So there are pros and cons of both. Having the straight one, it's very quick and easy to do. Doing it by hand with the mouse takes a little bit longer, but you may have a better fit of where the area of interest is on your stimulus. Okay, any other questions so far? Okay, so that's how you do a dynamic area of interest. And so again, this is kind of useful because it then, you can kind of, video eye tracking is very, very data rich. There is a lot there. And so by being able to sort of break it down in terms of, well, time spent looking at one object versus another, it gives you a way of simplifying this. Okay? Right. So this is one way in which you can analyze the data. The other two ways I want to show you involve actually representing the data on an aggregate basis. So less on an individual participant and more looking at how groups of participants actually interact with the data. So to do this, there's this little icon on the top right here, which is basically enter aggregate mode. What this will allow you to do is it allows you to show all the eye movements from all subjects at the same time on a video. So if you do this, it says, warning, you have entered aggregate mode. That's fine. And now if I play my video, which I have to group here. I'm going to group. So if I go trial grouping, and I'm just going to group by trial index for now. And then regroup. So again, what I'm just doing now is I'm showing all 6 subjects at the same time. Yeah, go File, Trial Grouping, Group by Trial Index. So what it's going to do is going to rearrange the data. So before we had it based on a subject, what we're going to do is now group over trial condition. In this case here, we've only got 1 trial, it's 1 video. And so it's going to, you see here now, my data on the left here in the inspector, you see, is now grouped by trial, and it's got subject 1, 2, 3, 4, 5, 6 inside that window. And what this will allow me to do now, because I'm in aggregate mode, it will actually, now I've got 1 circle reflecting each subject. And so now if I hit play, if I go back to the beginning of my video and hit, I'm going to put this back to 100%, and press play, you see now I've got all 6 subjects, eye movements superimposed on the same video. And again, like everything else, you can save that. So this is called aggregate view in Dataviewer. Some people call this a swarm analysis. So if you have a Toby or an SMI, they refer to it as a swarm analysis. So you can imagine each of these dots is a bee swarmed together.
Is there a way to identify each subject?
We're going to get there. Okay. So this is a simple way of just, literally it's just a single circle. Each circle reflects a subject. Now, you may also then want to generate some sort of average of this. And one way to do that is actually to click on the, just next to the Save button, there's this little button here, which is Enable Dynamic Heat Map in aggregate mode. What this will let us do is it'll let us generate a heat map that changes over time. So now if I hit go, now I have my dynamic heat map, which is now representing the overall where people are looking. So you can see here, most people are looking here, a little bit over there, but really most of my subjects, all they care about is the cat. And again, if you now hit save, you would save the video in that mode. Okay, so this is this sort of dynamic heat map is a very good way of kind of collecting an average of what your participants are actually doing. So based on the overall subjects, where are they going? What are they looking at? Okay, so it's very similar to the original heat map. It doesn't give you an index, though, of what it reflects. So basically, in this case here in the dynamic heat map, what it's reflecting is just the most frequently viewed location. So you can see here everyone at this frame in time is looking at the cat. Here, they're kind of split between the woman and the cat. But again, it gives you another way of describing the pattern of activity in your data. And you can see there are various trends. You can scroll through and see at certain time points. Most people care about the cat. Someone's checking out her rear end. Not the cat. And so, there are ways you could use this to describe the characteristics of what's going on. Obviously, if there's something interesting going on, everyone's looking at the same point. That's interesting. At the same time, when you start getting some variability in the pattern of eye movements, you can sit here and actually show that on the screen in the video. Now, the question that you had about identifying participants, we can actually do even better than that. We can actually have it so that we can actually separate out our participants into different conditions and actually have those marked differently on the screen. Okay, to do that, we're actually I'm gonna go back. I'm gonna take off that heat map mode and go back to the individual swarm. Okay, so right now you can see all my participants are kind of color-coded in purple. What I'm gonna do is I'm now going to regroup my participants. I'm going to take off the trial index for now, and I want to regroup them by gender. So again, I'm going File, Trial Grouping. I'm removing the trial index, and right now I want to group them by gender, and then hit Regroup. So you can see now on the left, I've now got my two groupings. I have all my female subjects and all my male subjects. Let's just take a look at the males. Okay, so here are my male subjects. So now I'm on my aggregate mode. Here, I'm only going to have 3 dots. So instead of showing all 6, because I've only got it highlighted with the males, it's only going to show my 3 participants over here. So let's see where the males look. Okay, so we now kind of know that the males are kind of split between the cat and the woman. Okay, just to see, well, what would happen in the females. I can go to my female only condition and run that. So they're looking at the cat, they're looking at the cat, they're looking at the cat. Oh, quick look there, but mostly they're spending more time looking at the cat, completely ignoring the owner. Okay, very cool. And I could sit there and I could have those 2 videos playing side by side. I could export them and you could show it like this. But there's a better way of doing it. That would be, what if we color-coded the dots so that the women have one color-coded dot and the men have another? Okay. What I can do here is, with the females highlighted, I can go down here and there's an option in my inspector that says applying color to visible events. I'm going to enable that and I'm going to color code it. So I'm going to say, let's make the females green. So green dots will now be associated with females. I could go do the same for males. Apply color coding, and I'm going to make the males red. Okay. What you see up here now in my inspector, you see all the female trial subjects now have been color coded green. All of my male subjects have now been color coded red. If I now go back and regroup my trials, take off gender, put it back to trial index, and hit regroup. Look up here on the left. So you see now I've got green, red, green, red, green, red. It still is keeping those color codes there, even though I'm regrouping my trials. What you'll also see now on the screen is I now have 2 sets of colored dots. 3 green, 3 red. I can now play my video. Oh, I need to have the video highlighted. That would help. Oh, why is this not?
Yeah.
Click on YouTube. Yeah. Not showing for me too.
Mine's been phasing in and out. I'm not sure why.
This did not happen this morning. Hang on, let me just try ungrouping this. There we go. So that's my one subject. Let's go back up here. Go File, Regroup, based on trial index. Regroup. Now play. There we go. This is something I've discovered with the video, is that sometimes if it does disappear, just ungroup everything, find a trial that works, and then regroup, and it works perfectly fine. Don't ask me why. It's a glitch with the program. So you can see here now, my green dots are my females, my red dot is my males. And it's another way in which you can sort of sit there and interact and show, well, okay, well, collectively, where are the men looking? Where are the female looking? Where are they behaving the same? Where are they behaving differently? Okay, so it gives you another tool that you could add in. And this could be, you could have this based on individual subjects having individual color differences. So all I would have to do is click on one single subject, and I could go and change their color. So this could be groups, which is probably the one that would be most useful. But if you wanted to go on an individual subject basis, you could bring each subject up, have them all have a different color, and put those together. And that would be another way in which you could analyze your data. So it could be an individual basis, it could be based on groups, it could be based on conditions or whatever. It really doesn't matter. That color coding just helps you then parse out the differences. Likewise, I forgot to say as well, if you have it, for example, males versus females, if you clicked on the dynamic heat map, it would generate only a heat map for males or only a heat map for females. At the moment, you can't have two groups of heat maps superimposed on the same video, unfortunately. Maybe they'll do that in the future, but for now, if you want to compare conditions in a video, right now the swarm analysis is the only way to do it. Any questions? So hopefully you can see, I mean, this is has a lot of potential for, especially when it comes to analyzing video, because now you can sit there and you can generate your numbers via an interest area report, but also you can actually get a sort of a more sort of descriptive way of saying, okay, generally, when I'm watching the video, am I seeing patterns of behavior which then reflect through on the interest area report? And the ability to sort of save at any point this as a video, which then you can use in talks or even in publications, is quite a useful feature. So analyzing dynamic videos is quite difficult because many of the usual ways of describing eye movement metrics are not yet compatible with moving stimuli. So for example, defining a fixation in a video is very difficult because, well, a fixation usually in most eye tracking algorithms is a pause in eye movement for a particular duration within a certain area. Well, in this case here, you've got a moving stimulus as well. So a pause could be that you're maintaining fixation on, for example, my cat as it moves across the screen. You could define that in a video as being it's a fixation, but it's maintaining fixation on a target as the target is moving. But your usual algorithms, so if you go into the fixation report, they will not do that. What you can do is you can go into the interest area report and say, okay, time spent looking at that interest area, and that could be some way of defining a fixation on that one target.
And I presume it would be also difficult to assess or evaluate or interpret the cognitive processing that occurs in fixation on a moving target rather than on a fixated target.
Yeah, and this, video is, there are some people who are starting to do video analysis, but it's really sort of in its infancy. Part of the problem is just, for a static image, you've seen that we can generate a lot of data. Now take that image, move it 30 times a second. Over time, this generates a obscene amount of data, and it's sort of finding ways of analyzing this or crunching it down to the point where we can actually make sense of it is quite difficult. There are a number of labs around the world who are trying to do this. There's a very good researcher in the United Kingdom at UCL, Tim Smith. Tim is kind of leading the way in terms of video analysis. John Henderson, who is now in California. Those are sort of two researchers where if you want to look up people who are doing video-based analyses and actually making sense of it. Both of them are researchers who are at the sort of leading edge of the field. Yes. No, he does eye tracking. Yeah. Okay, so